This drone is powered by a battery on the bottom. This is battery number 4. And I'm going to power it up here. You're going to hear it wake up. There it goes. You see the little propellers twitching. There's the fan. And it's awake. So you can see a couple different things on here. There's the forward LED lights. These are red. And on the back, it's kind of hard to see because it's flashing, it's a green LED light. And this will be important later on when you're looking at the video of the mapping. Knowing where the red and the green are on the little icon will tell you which direction it's facing. Is it going this way? Is it going this way? Because a drone can map going forward, backwards, sideways, up and down. Right? And the way it does the mapping is it has a little 4K camera. You can see it kind of moving around a little bit. It's on a gimbal. This is a 4K camera that takes, depends on the flight you go, but at about 100 meters, which is what I normally fly at, the resolution is probably about 1 centimeter or so. So you can't read a newspaper, but you can get a pretty accurate estimate of the size of things. So if you have something on the beach, if you want to count number of things like seals or people or umbrellas, whatever you want to count, it's pretty accurate. So it's a good way to collect a lot of data. So I'm going to power this off so I don't annoy you with the lights. It's really loud, in case you didn't hear that. It's got a little computer in here, so it's hard to see right there, but it has an air vent that it brings air in. It also has on the back, since we're looking here, see if you can see it right above that light, that's where the SD cards are. So a lot of mapping takes up a lot of memory. So it's pretty easy to collect, 3 to 4 gigs of data on a single 5 to 10 minute mapping. So you want to make sure you have some good SD cards. Other features I want you to be familiar with on here is the antennas are actually, hold it up so you can see it, these things right here. Those are the antennas. This is actually how the drone talks to your base station. So the base station, sorry about that, is this. So this is a base station. This talks to the drone through a Wi-Fi. It's a dedicated Wi-Fi. So the Wi-Fi on the drone is connected to this. And that's how it talks to you, and that's how you control it, right? It's got little joysticks, you can do things with it. So on the drone, you have on the front, this is the front, the camera, you also have forward-looking sensors. So if you're flying into something you don't want to hit, right? So these little sensors tell you that, you might hit something. And of course, you got sensors on the back, those two right there, and you also have sensors on the bottom, right there. So you got 2 of them. Actually, got 4 of them. And 2 of them are for obstacle detection, so making sure you don't hit anything. And the other 2 are actually for elevation. So I'm not going to go into a lot of details, but the drone can estimate how high it is based on barometric pressure, but also it can estimate the distance from the ground by using these sensors as well. The one that you're going to be using is Project 10. This is the one of the beach mapping that we did, so you'll be using this one for the assignment. If we select Project 10, it'll draw an overview of what the map plan looked like, and I showed you in the previous video how to do this. You can overlay it on the satellite so you can kind of look for features, and after the mission is completed, you can scroll through the right-hand side to make sure the images look good. And these are the images that are actually uploaded directly to the cloud for processing, but this is a nice way to look at it. Here's the summary of that mapping. You'll need this for the assignment. With respect to dimensions and height, it's all there. This is an aerial map of Huntington Beach State Park, which is near Murrells Inlet, South Carolina. And the image that you see that is kind of the nice photo on here, this is the drone image that we took. So this is actually 43 different images that have been stitched together into what's called an orthomosaic. And what I'm going to do is walk you through the concepts I want you to get out of this. And so with this assignment, I want you to be familiar and able to work with data and images collected remotely. So not just for drones, but this is useful for like AUVs and other things like that. We're also going to use a special software excuse me, called Pix4D, and this is going to allow you to calculate areas and distances from images, and you'll also be using this information for your field trip. So the skills you'll get in this are going to be used for those also. We're also going to introduce the concept of a Julian calendar and how you use it to estimate time and dates, which is a super handy thing when you're in marine science trying to figure out when things should happen. And then finally, we're going to introduce the NOAA website to estimate tidal heights for current and also historical and future times. So what we're going to start with is the first question in your assignment is the following. So with regards to this mapping project, the question 1 is, what was the time, height, and flight time of the beach mapping project that you will be using? So the second question is using the Pix4D mapper, so this software here, and that will be in the link that you were sent by me. I would like for you to calculate 2 values. So this is for a total of 20 points. So the area of the blue landing pad, and I'll show you where this is in a minute, and the distance from the landing pad to the nearby sea turtle nest. So let's zoom in a little bit. So here on the right-hand side, you can see the toolbar. So we're going to zoom in a little bit. And just to orient you, so it's hard to see, but right there, right where the cursor is. You see that? That's the blue landing pad. So we're going to zoom in a little bit. It'll get a little clearer. You can see an H on it. There we go. There's the H. So here I am. That's me standing right next to it. And what I want you to do for this particular assignment is I want you to calculate the area of this blue landing pad. And so there's a lot of different ways to do this. And so what we're going to do is in this top right-hand bar, see that little square? If you click on that, that will allow you to draw different shapes on the image, and it will give you resulting numbers. So what we're going to do is pretty simple. We're just going to click around, and I'm not going to be super careful with this because I want you to actually be pretty careful with this. So as you kind of click around, you see I'm going a little too far out. It'll give you the area, right? So this is 6.33 square feet, and that's really it. Now, what you can also do, we'll get rid of this. What you can also do is measure distance, and you do that with this line. So you can measure how far I am from there. That's kind of useful. I'm about 10 feet away from it. That's kind of cool. But also, what I want to show you is the sea turtle nest, which is going to be the main part of this assignment. Oops. So we're going to zoom out a little bit. We're going to grab this arrow right here so we can kind of scroll through. Zoom out a little bit. All right, so right here, actually let's zoom in so you can see it. You see that square right there? That is a sea turtle nest. And so what I want you to do is to measure the distance from this blue landing pad to this sea turtle nest. And when you do that, it'll give you some number. And that's really all I want you to do for this one, is to measure that distance, to get used to measuring things, measuring areas, etc. So that's question 2. Now, you will note that when you do measurements, you can either do a screenshot of this, or you can do a screenshot of the calculations on the right. Regardless, for this assignment, you need to turn in a screenshot for full credit. So that's question 2. Let's talk about question 3. So let's zoom out a little bit again. We need the full scale here. So we're going to grab this little cursor and drag it down. So for question 3, excuse me, when you look at this mapping project overlaid on top of the reference map, and here, let's turn it off so you can see it. So this is the reference map. This is essentially Google Earth from, I think, 2018. So this is Google Earth. And if we add in our image, our orthomosaic, it puts it right on top of it, right? So you can see that, off, on, etc. So one thing you'll notice is that the dunes, this is the beach face right here, the dunes right here, whoops, sorry about that. The dunes here with kind of the vegetation look a little bit different than here, right? So let's do that again. We'll turn it off again. So you see this area right here has vegetation, but it's gone. So what I want you to do is figure out this area, this distance, this area between the two images. And so it's the same thing you just did for the blue landing pad. essentially you just kind of eyeball. So here you can see, you know, there's some vegetation here. So the vegetation starts right about there, goes up to about there. We're going to run all the way up here. And then the vegetation stops somewhere right about here, right? And so that's the area I want you to estimate. And the reason this is important is because this is the area that has been increased in the beach phase. So this is actually maybe a good thing for sea turtles, or maybe a bad thing. And we'll talk about that a little bit in lab. But what I want you to be able to do is estimate this area. So essentially change in the dunes. So again, you'll need a screenshot for this one as well. So that's question 3. Now, question 4 is a little bit different. You'll probably have noticed that this area, see if I can find it. Here we go. You will probably notice, where'd it go? There it is. You'll probably notice this area right here, that sea turtle nest, is currently in the upper part of the beach. But if we turn off our drone map, kind of mark where this space, actually let's do that. Let's put a mark right there. If we turn off our map, where is it? It's right in the middle of all that vegetation. So this sea turtle nest that we're looking at is actually in this newly formed beach. So what I want you to do is we're going to find out a little bit more about the sea turtle nest. Now, the sea turtle nest, if you look at the image on the handout, tells you it was laid on June the 7th, 2020, which is just a few weeks before I did this mapping. On, I believe it was June 26th. Yeah, that's when I did it. So what I want you to do is we're going to use a Julian calendar. So we're going to introduce this concept of a Julian calendar. And this is the link to the one I showed you. Let's zoom in a little bit. So it is 2020, so it's a leap year, so we're going to use the left-hand side. And what we're going to look for is when the nest was laid, which is June 7th. So we find June right here, and we go down to 7th. So June 7th is the 159th day of 2020. Now, we know roughly that loggerhead sea turtle eggs take about 60 days to hatch. So you can add 60 days to 159, and you'll get some number, and you can figure out, let's say that number is this, 228. That nest should hatch on August 15th, right? And this is the nice thing about Julian calendars is, you know, if I just want to say what's going to happen 43 days from now, you can figure it out really simply with the Julian calendar instead of counting days individually on a regular calendar, right? So what you need to do for question 4 is using the information on the turtle nest and this Julian calendar, please show the Julian date. So you can just write the day. So, you know, if it were August 15th, you'd write August 15th, Julian day 228. Okay, and that's really all it is. All right, so question 5. Question 5 is also related to this particular sea turtle nest. So just kind of reorient ourselves. There's the nest. The next question is using the NOAA tide predictor, and again, the link is in the handout, and it's also represented here. Please calculate the tidal height for when the sea turtle nest was laid using the spring-made pier near Myrtle Beach. Now, the reason I picked the spring-made pier is this is the closest NOAA gauge to this sea turtle nest. So there's, you know, gauges aren't all over the place. You have to pick the closest one. So this station, ID 8661070, is this one here. So this is spring-made pier. And if you scroll down, you can change whatever date you want. So the date that we're interested in is June 7th. So we're going to pick the day before, so June 6th. And we want to look through, let's say June 8th, right? We'll kind of bracket that day. We'll see what it looks like. And this is what it looks like, right? So this is the tide on June 6th through June 8th for 2020. Now, the nest was laid on June 7th, so let's find June 7th. Okay, so here's June 7th, around 2:55 p.m. So here's 12 p.m., there's 6 p.m. So you can kind of play around with where that number is. So you can figure out where the tide was when the turtle laid its eggs. Was it high tide? Was it low tide? Was it rising? Was it falling? You can answer all sorts of interesting questions about that. So you need to tell me the tidal height in feet. So for example, if she were to lay her eggs at roughly 9:19 in the morning on June 7th, the tide height would have been about 4.95 feet. But if she were to lay it later on in the day, about 3:30, it would be minus 0.37 feet. Okay, so that's what I'm looking for, is the tide height. Now, the final question is, using the tidal height from question 5, which you just figured out, in the same station, which we're already here, I want you to estimate the tidal height for when I did the drone mapping. And this was on June 26th at about 11:30 in the morning. So what we're going to do is change this to June 26th. June 26th. We're going to do the same thing. Okay, so this is the tide for when I was mapping on June 26th. So about 11:30 in the morning, so right somewhere between 10 and 12, that's where the tide was. So using this information, I want you to answer the question of, was the tide higher or lower when the sea turtle eggs were laid on June 7th compared to when I was there on June 26th? Okay, and that's really all the questions